Okay, so welcome for today's session. So today we're going to discuss on the basics of communication system. So we'll be looking at the block diagram of the communication system. Then we'll talk about the mobile communication and the cellular internal architecture. So this will be the last topic of this module, which we'll be talking about. So now, as you can see here, just a minute, let me adjust my screen. Yes. So the basic communication system, if you look into the block diagram here, so it will be having the information source, that is the input transducer, then we have the transmitter, and then we have the channel and receiver, and there is one more component which will get added, so that we call it as the noise. So now, for example, if you want to transmit any signal, it might be a digital signal or it might be an analog signal, we have to transmit it to a longer distance. So if you want to transmit it to a longer distance, we have to perform lot of sequence of operations on it. For example, if you have say the speech signal which you are listening right now, if you want to transmit at your location, then I have to convert my speech, my audio signal, which is in the form of analog form, that with the help of microphone I have to convert this into a digital form, a sinusoidal electrical form. Then from that electrical sinusoidal form, then I may transmit it in the same form by modulation, or I can convert that into digital by doing sampling and converting it to digital. Then I can perform the digital modulation, then I can transmit through the channel. So there are different methods of transmitting. So if we talk about, say, a communication system here, that is for example, if my source here is, say, a sinusoidal signal, something like this, then I can transmit. So this is my modulating signal here, so that we call it as the information signal. So if I want to transmit this information signal, what I need to do is that I have to put this on the high frequency carrier. So this we call it as the high frequency carrier. So because this signal what I am speaking, or the speech signal which is of low frequency, it cannot transmit a longer distance if you just transmit it just like that, because we require a very high antenna, very tall antenna to transmit this low frequency signals. So that is why what we'll do is that we'll put this signal on this carrier signal. So that process we call it as modulation. So that with the help of modulation, what we can do is that we can transmit this signal to a longer distance with the shorter antennas, or the short height antennas, because we know the frequency and the lambda, they are related with the formula, that is C is equal to, lambda is equal to C by F. So if the frequency and lambda are inversely proportional to each other, and the speed is determined by the speed of light, that is 3 × 10 to the power of 8. So now there are different types of modulators. There might be a frequency modulator, or a amplitude modulator, or phase modulator. This is about the analog modulators. So if the same thing, if I sample this signal, for example, let me erase this here and write this signal here. So if I have the same analog signal here, so if rather than transmitting the entire analog signal, what I'll do sampling, and I'll convert these values to digital form. So these digital values I can modulate again. So for example, I have sampled this entire signal here. So after sampling, I'll obtain the codes, and by using some kind of waveforms, so either I can do a binary modulation, that is a binary frequency shift keying, or binary amplitude shift keying. So like this kind of modulations I can perform, and I can transmit this. So how do I transmit this? So I can transmit this either with the help of cables, that is connected from transmitter to receiver. For example, if I want to transmit my voice from here to say your phone, if you are calling, so if it is a landline phone, then through a copper wire it is connected from one end to the another end to exchange, and then from exchange to the other end of the receiver. So it can be a copper wire, that is the one of the medium here. So the channel which we are talking about here, it can be of any type. So it can be a free space as well. I can transmit through this antenna. So this open space acts as the channel again. So that is in the form of wireless. So for example, your mobile phones, till the tower, all the signals will reach in the wireless fashion. So that is another channel. So if you talk about another channel, then it is optical fiber. For example, we convert the signals in a form of light, and then we are inducing that into the an optical fiber, and through in a form of light, through in the optical fiber, we are transmitting that information from the transmitter to the receiver. So if we see throughout the continents, how the information is passed, or whether it might be a phone calls or it might be a television channels. So it is intercontinental, the transatlantic optical fibers that are laid down in the seas. So that is also a kind of channel between the two transmitter and the receiver part. So when we are transmitting this signal, whether through a wireless or through an antenna or through an optical fiber or through what do you say through optical fiber or copper wire or wireless, so there will be a noise that is get added up, because whatever we transmit, it will get added up with the additional noise which it goes through this environment. So if we talk about the wireless, the signal is in the electromagnetic form. It will be traveling from transmitter to receiver, and along with that there are other frequencies also exist in this free space, so that will act as the interference to this signal which we have transmitted, so that acts as a noise. And in case of copper wire also, it might be a power noise or some kind of cross this the cross talk or impedance or something, the high electrical power lines, so that's also interfere, that will also introduce the interference in the channel. So like this kind of noise will get added up in the channel, and at the receiver it is not only the detection, it is also to free out all these noises. So first it has to select the particular channel, and then it has to filter out the unwanted noise, and then it has to perform the demodulation. The demodulation is a reverse process of the modulation, and then after demodulation and performing lot of amplifications, then it will give to the particular destination. Destination can be your monitor screen where you can see the text or anything like that, or it can be the speaker where you can listen the voice if it is transmitted from one end and received at the other end. So it can be anything. So that is the destination which we are talking about. So this is the basic block diagram of the communication system. So hope you have understood. So these are the general basic parts if we talk about. So one is it has the information source which generates the information through a transducer. That might be in electrical form, that might be your mic or your digital systems or anything, or it might be a sensors as well. So sensors are also a transducers which are converting your physical parameters into electrical form, and then we are transmitting it through first we perform the modulation, and then from the modulation we are transmitting it through either copper wire or free or through antenna or optical fiber. In that we call it as a channel, and in the channel the noise will get introduced, and at the receiver we have to select the particular channel which with the same means we have to receive it, and then we have to filter out the noise, and then we have to amplify the signal, we have to perform the demodulation process, and then we finally give it to the destination part. So this is about the block diagram. So now let us talk about the principles of operation of mobile phones. So you all use the mobile phones, you already know it. So if I talk about the working of this mobile operation, so the entire system we call it as a GSM, that is a global system for mobile communication. So the GSM stands for that. So here what everybody are aware that there are towers. So you will be in some place here where you will be, for example, if you consider this is you and you're having some mobile phone with you, so then the mobile phone is a wireless device, it is not connected through wire, so it's a wireless device. So if you want to communicate to any other person through mobile phone, what will you do is that you will dial the number, and it will reach to the destination. But how internally it will work, so that we need to understand here. So always this mobile phone, when it is turned on, it will be in the contact with the local tower. in that cell. So the geographical area is splitted into cells. So the geographical area, when there is a tower, when there is a tower to connect to the mobile phones in that area, it has certain radius. For example, if there is one tower here, if this is a tower, so this tower has certain radius. So for example, the practical is that it covers certain distance on the in a circular fashion, so based on the type of antenna that is mounted on this tower. So just for mathematical analysis, this circle is represented in a form of hexagonal shapes. So this hexagonal shape of the network coverage area, we call this as cell. We call this as cell. So this is one cell, whereas this is the another cell which is covered by a one more tower, and this is the another cell which is covered by the another tower. So likewise, wherever tower is there, so that tower covers certain radius of distance of the signals in that radius, so that we call it as a cell. So for example, if you are in this cell here, and if you have the mobile phone, that mobile phone is wirelessly connected to this tower. Only till this tower it is wirelessly connected, and after that through this tower there might be an optical fiber, or it might be a copper cable that might be running from this tower to the local exchange or to the BTS that we're going to talk about later. So this is about the cellular concepts. So I'll not go much in detail of the cellular concepts, because there are various kinds of cellular concepts. There is called as a cell sectoring, cell reuse concepts. That is way beyond your syllabus. So there is something called a cell reuse. I'll just give a little introduction to that. Cell frequency reuse. For example, if you take any of the vendor which you have, for example Idea, Airtel or Vodafone, they will be given a set of band of frequencies. So for example, they are given the band of frequencies of 800 megahertz, then the 800.1 megahertz, and 6 megahertz or something like this. They have given the frequencies, so frequency bands. So it means to communicate one person, so one mobile phone requires some set of actually 4 channels. I'll not confuse you much, so let us restrict to only 2 channels, because I'll not talk about the control channels here. I'll just talk about the voice channels which is required. So because whatever the communication you do, it is a two-way communication, so that we call it as a duplex communication. So duplex communication means at a time the person who is here, who can transmit the signal, also he can receive the signal. So for that, at the same time, since you're doing, so you need two separate two separate audio channels. Two separate frequencies are required. So two separate frequencies are allocated for this person or for this mobile phone. So likewise, in this tower, for this tower there might be a couple of, say, 10 couple frequencies are allotted. So for example, there are 10 frequencies, couple frequencies I'm talking, because if it is needs to allocate for one person here, then it need to allocate 2 frequencies. So I'm talking in terms of the couple frequencies. So like this, for example, in this tower, so let's talk about only one scenario. Let us consider that any one kind of tower is there. We will not talk about the multiple different vendors. We will stick to just say maybe Airtel is the one vendor in this entire area and has one tower. And if the 10 dual band frequencies are allocated to this, then at a time how many users can be active? So this is so what do you think? So at a time, then 10 people can make a call. If the 11th person make a call, then there will be a call drop. So this kind of call drops you may face in the urban cities where there is a huge traffic, or there might be a gathering. For example, if there is a huge gathering in some places, and in such place there will be a network overloaded. The tower is overloaded with so many calls, because there are so many persons are gathered in the same place and they are all connected to this one particular tower. then the calls will not be routed, so call will get dropped. So now if all the 10 users are on the active call, then the 11th person, if it makes the try to make a call, then the call will get dropped. So the 11th person can get the frequency get allocated only when one of the person who is in the call can disconnect it. So that is the real-time problem here. And the another problem is that, so if the 10 frequencies, the TROI is the organization of India, that is a Telecom Regulatory Authority of India. So this will call for auction of the frequency bands for the vendors frequently, maybe every year or based on the demand. So they will allocate certain frequency bands for the vendors, and this they will call the auction. And it's the frequency bands are very small, and with that small number of frequencies they have, how do they allocate, how do they accommodate their thousands or lakhs of customers throughout the country? So that is a $1 million question. So there comes the concept of the frequency reuse. So what is a frequency reuse is that, for example, if I am allocating these frequencies to this first cell here, in this first cell, then the same frequencies I will not be allocating in this second cell, third cell and fourth cell, because these are the adjacent cells, because that will cause the interference. So I can accommodate the same frequencies at this fifth cell at far distant, at this point where the cell, this cell number 1 and the cell number 5 are physically separated to a certain distance, that this signal from the cell 1, from this tower 1, will not reach this area. So in such case, what we can do is that I can reuse the same frequencies here in the area 5 with the tower 5. So this is the concept, we call it as the cell frequency reuse. And through this concept itself, the vendors with the small, with the say 100 bands of frequencies or 50 bands of frequencies, they can accommodate their thousands and lakhs of customers throughout the states or throughout the country. So this is the called as the cell frequency reuse. And there is another concept, there is something called sectoring. So sectoring is another concept. For example, rather than having an omnidirectional antenna which covers the entire cell, I am going to sector this in this way. I am going to sector maybe something like this. Yeah, something like this. So how many, now each cell is split into cell sectors. Now there are 3 sectors. If you see here, this is 1, 2 and 3. Now what happened is that now I have, rather than having an omnidirectional antenna, here I can put something called the directional antenna, which can cover, if I put the directional antenna here, then it covers only this part, that is the sector 3 part, the small area here. And this the another antenna, so it means definitely the installation cost increases, because I need 3 separate antennas. I need to install this in 3 different directions. So these are like 120-degree apart. If you look at the geometry of this setup of antenna, so then these are something like this, which with an angle of 120-degree. The antennas are set up in that way. So even with this also we can increase the frequency reuse concepts. So these are the different methods how we can increase the frequencies which we have to increase the number of customers or support the number of customers. So I can tell you what is the advantage when compared to the cell number 1 and cell number 2. Now here the same 10 couple frequencies are allocated for this cell here, and now each cell again split that into 3 parts, and then it supports the 3 sectors, and then it can shift the load, or there is something called the frequency borrowing. If this cell is completely full with means it allocates all the frequencies, and still there are more number of customers that are trying to call, and it's not able to accommodate, then if the neighboring cell, if it is not using any particular frequency, or if there are no more calls in the nearby next tower, so they can borrow those frequencies on a temporary basis, and then they can support the number of customers. So there are many concepts when we talk about the wireless communication. The wireless communication itself is a wide topic. I'll not go much in detail on this. So this is about the introduction of the cell concept. So this is the cell concept which has come later in the recent years. So previously what was there, for example, previously in olden days, if you see when the mobile towers has come uh, at the initial stage, then there is a concept called only one tower in the entire town. For the entire town, for an entire 50 kilometers of radius, there is only one tower and it is supporting all the customers. But as the number of customers have increased, then this single tower was not able to accommodate all the customers. So then they have come up with a concept of called this cells and frequency reuse in the cells and sectoring of cells. So like this, there are many various concepts have come in later to increase the number of customers and to satisfy their needs. So now let us look into the structure of uh, you know the GSM, the structure of GSM. So GSM stands for the Global System for Mobile Communication System, or Global System for Mobiles. So the I'm going to relate this again with the cells and this. So now you are here in this one cell, in the cell number 1, and you have the mobile device. So that is the term for the mobile device. It is called as ME. It is designated as ME. This is a standard term which used in the communication system. So ME means it's a mobile equipment, and inside the mobile equipment there is a SIM, so that everybody knows it. You have to insert the SIM card for GSM phones. For CDMA, it is not required. CDMA, it's already like a code number is already there in the mobile phones. So now that CDMA phones are not there. In the previous, in the last decade, the Reliance had launched the CDMA phones. The time now, I don't think it's much in use. Yeah. So then, this mobile to this tower is the wireless connection. There is no physical connection, it is the wireless connection. So that you are connecting to BTS. So the tower is called as the BTS. So this is called as BTS. And this BTS, this towers, is internally connected through an optical fiber, or it might be through copper cable. It is connected to BSC. So BSC is BTS stands for base transceiver station. BSC stands for base station uh, controller. So BSC stands for base station controller. So for example, 8 towers, for example this cell number 1, 2, 3, 4, 5, 6. So all these 6 tower are connected to single BSC. It means one BSC can accommodate a maximum of 8 BTS. Let us take the technical terms. Let us not call this as towers. So tower is a layman language. So if you talk in terms of technical, these towers are called as BTS. It is base transceiver stations, because it is going to transmit as well as receive the information from the user wirelessly. So these are called as BTS. So these BTS, so this is another BTS here. This is another BTS here, and this is another BTS. So all these BTS through this cable. So from this there will be a cable running like this. There will be a cable running like this. There will be a cable running from here. So like this, the cables are connected to the BSC like this. So there are different BTS. So from all these BTS, it is connected to BSC, that is a base station controller. So it is going to control the frequency allocations for these towers, the signal strength, the power, and controlling of all these BTSs. It is done by BSC. And then similar kind of such BSCs are connected to MSC. It is called as the mobile switching center. So here is the main operation that will takes place, that is the switching from the circuit switching or packet switching that takes place when you're making a call. That I'll tell you later. And this MSC is connected with this various databases. That is, MSC is nothing but it is the exchange, the main exchange that you can think of. And then so this is connected to, say, it is having the database like home location register, visitor location register, EIR, that is the equipment identification register, and ABC is authentication database. So all this is connected, and then this MSC is connected to maybe another MSC, or it might be connected to PST, and that is public switch telephone network. So now let us understand how the call get connected. When you dial a number and make a call, how internally the function takes place. Now for example, you are here in the cell number 1, and here this might be a cell number 10 here, and you are trying to connect to a person who is in the other area of other town, or it may be a same town, it depends on the geographical distribution. So for example, you are making a call from here to the person who is here. So now when you dial the number, what happens, all your details through the control channel, it is connected to the tower, and the tower will transfer, that is BTS. So that BTS will take all your information like who you are, what is your IMEA number, what is your device, that is a mobile equipment number, what is the SIM number. All these details are carried forward to BSC, that is a base station controller, and base station controller will forward this to MSC. MSC is the exchange. So in MSC, all your details are checked in fraction of seconds, in terms of microseconds. So whether you are from the same state, so this is something called the circle. So circle means the Karnataka is one circle, like that Tamil Nadu is another circle, like Kerala is another circle. So this we call it as one circle. So you might have seen when you're moving from one state to another state, automatically the tower will change from home location to say roaming. So you can see that internet will show you are in the roaming now. So like this, so this entire state, if you have purchased the SIM from Karnataka, then you are in the Karnataka circle. So it will check all your details. So all your details when you fill the application while taking the SIM card, so that will all be uploaded in the HLR, home location register. Means what is your name, who you are, what is your address, and what is the device that you are using, what is the IME number of your device, and whether you are authentic device or you are whitelisted. So all your information is available here, and then it will check the authentication. Authentication means whether you have the sufficient balance in your mobile phone, or you are blacklisted customer, or you whitelisted customer. All these kind of verifications are done here in the authentication unit, and then all your device information is checked in EIR, that is equipment identification register. Means your SIM number, your mobile number, and your IMEI number, whether he is an authentic person or somebody non-authentic person. So all these device per se information will be available in this EIR, so that will be checked here. So when everything is fine, then this MSC will make a switch contact. Means it is something called switch there. So then switch will connect to that another person, and then it will start searching in the all the nearest towers in the last location. Why? Because when you're using the mobile phone, without your knowledge, for every 10 seconds or 10 milliseconds, your mobile phone will be sending some kind of information to the tower. So that records your what is the current location. So whether you are connected to this tower or BTS, whether you are connected to BTS 1 or BTS 2, BTS 3. So that is how you can be continuously connected with the network. So for example, if you're calling for the second person, and the second person, the last location was somewhere in the say BTS 10, then this MSC will suddenly make a contact. It will check the person also, and also it will check all the details of the person to whom you are calling, whether that person is authentic or he has all the valid this thing, and it will check whether his details and his equipment number, everything. And once everything is fine, it will make a contact, and it will give the control signal in the tower PST 10, and then from that tower a signal is passed to that particular mobile number, and then it start ringing, and it will be ringing until unless the receiver or the user and second user receives the call. Once it receives the call, it will disconnect the control channels, and then it will allocate the voice channels which are required to communicate. Then the communication is established between the first customer and the second customer, and now they are exchanging their information. So as long as they are both connected, so that same frequency will be allocated, and once they disconnect the call, then the frequency will get back into the pool of this tower or BTS, I can say. Now I have not talked about what is this VLR. So VLR is a visitor location register. Now for example, you are moving from here to say from Karnataka, you are moving to Tamil Nadu. Actually, you are a resident and you have purchased the SIM in Karnataka, so you belongs to a Karnataka circle. But when you move to Tamil Nadu, so what happened is that, so you are a roaming person there. It means you are a guest to the other circle. So then all your information is temporarily copied to VLR, the MSC VLR of that particular circle. So from all the information that is there in the HLR, that will be copied to VLR for a temporary basis, as long as you are there in the other circle. As long as you are there in the other circle, all the informations, when you make a call from say other circle to back to Karnataka or maybe anywhere else, so that MSC from Tamil Nadu, it will going to check it's all your information from the local MSC, the Tamil Nadu MSC, and that VLR database. So that VLR database has all your information that is temporarily stored there in Tamil Nadu when you visited there, and once everything is fine, then it will connect the contact to the to who are you calling. So there the contact is established. So PSTN is another kind of network. For example, if you're calling from mobile to landline, so then MSC, the same process will carry forward till here, and after this, the information, the MSC is connected to PSTN, that is Public Switch Telephone Network. That's another kind of network. So it is connected to that landline number in the same way. Now we'll talk about some of the standard interfaces. Now the mobile and the BTS, these are connected wirelessly. So this standard term, we call it as UM connection. For example, you connect USB to your mobile, so how do you connect it to your laptop? So that is the USB connection. So USB is a standard term. So likewise, for this wireless connection from mobile to BTS, so this we call it as UM. Likewise, the connection from BTS to BSC, this is called as ABIS. So the term is ABIS. And the connection from BSC to MSC, we call it as A connection. So these are the connection interface standard terms. So UM means it's very clearly understood. So for example, for an engineer, they are rectifying some error. For example, there is some problem and the two engineers are talking. So where is the problem? If somebody asks, if one engineer asks to another engineer, then he will say the problem is in the ABIS connection, or the problem is in the A connection. Means, for example, during some natural calamities, there might be possibility that the cables will get disconnected or broken due to some natural calamities. So then, which wire is connected, whether it's a connection from BSC to MSC is lost, or BTS to BSC is lost, or is a problem with UM connection. So then they will use the standard term, and it is very clear for the other engineer, okay, so this is the problem and this is where it exists. So everywhere they use some standard terms. This is global standards which we use it. Okay, so UM is for wireless connection, and then ABIS is for BTS to BSC, and BSC to MSC we call it as A connection. Okay, so now let us talk about the last topic of this here we'll talk about the cellular telephone unit. For example, we will not go in much detail again. We'll just look into the block diagram of your handset. Nowadays the handsets are pretty much way powerful than this block diagram, because it's a smartphones. But if you talk about the conventional handsets, basically it consists of only these blocks. So it has a control unit, logic unit, receiver, transmitter, frequency synthesizer, and an antenna. So this is a basic setup of your mobile phone. So frequency synthesizer, why? Because the transmitting frequencies and receiving frequencies from the BTS are different. So the frequency synthesizer will going to generate those frequencies to demodulate those transmitted signal as well as the received signal, and that information is given from the control unit. So control unit will give the what frequency that is allocated from BTS to the mobile phone, because every time it is not the same frequency which is allotted. Every time there is a different frequencies which is allotted Now if I talk about the frequencies which are allocated to the transmitter and receiver, so it might be say 825 to 845 megahertz frequencies. We are talking about one particular frequency, and in that the channel 1 might be 825.03 megahertz, 0.03 megahertz. This might be a channel 1. So likewise 825.06 megahertz is the second channel, and so on like this. We can form up to 666 channels within these the transmitting frequencies. And if I talk about the receiving frequencies, then the receiving frequencies I can have somewhere from 870 to 870.03 megahertz to 889 megahertz. So same 666 channels are available. So out of which few we'll use for transmission and few we'll use for reception channels. So let me write. So receiving channel frequencies may be 70.03 megahertz to 889.98 megahertz. So these are the transmitting and receiving frequencies if we talk about. So only see, I told you when discussing about the cell concept, there are only 666 channels are available. So how to efficiently use it means at a time only 600 customers can talk. Very surprising. That is not possible. Throughout the Karnataka, can you think only 600 people are talking? No, that is not possible. We have to increase the number of customers. There are lakhs of customers inside the Karnataka itself. So simultaneously there might be 10,000 calls which are going. So how do we accommodate with this 666 channels? So that is where this concept of frequency reuse comes into picture. The cell splitting comes into picture. Okay. So hope you understood this session. So thank you for joining this session. If you have any queries, you can ask.